Alright guys, so today we are going to give this weekly contest 4878. So yeah, let's see how it goes. Count the elements with at least k greater than. You are given an integer array nums of length n and an integer k. Okay. An element in nums is said to be qualified if there exist at least k elements in the array which are strictly greater than it. Okay. Nums is said to be qualified if there exist at least k elements which are that are strictly greater than it. Return an integer in total number of qualified elements. I can just use a stack, monotonic stack to do this. So I'll be going to go from the back side and I'll be like, let's say I'm having a val which is going to tell me how many values are greater. So yeah, I'm also going to have let's take this variable n as the length of the array, and yeah, okay, so I'm going to start from the back side of the array, and initially these values are 0. Okay, so now I'm also going to initially obviously the last element there is nothing. Okay, wait, not on the it doesn't say that it should be on the right side of the array. It just says that it should just at least k elements which are strictly greater than it. Okay, so I can just directly sort nums dot int. Okay, okay, so I'm going to start from I equals to n minus 2, I is less than equals to 0, I minus, and if I find out that if, so I'm also going to have answer as, if I find out that nums of I is not equals to nums of I plus 1, then if nums of I plus 1 is actually, what is going to happen, n minus I is how many I am at particular ith element, and n minus I is just going to give me how many elements. So I need to have this n minus I if it is greater than or equals to k, right? Then I will be like answer plus equal plus. Okay, that's what I'm going to do. And okay, I also going to okay, wait. That should be strictly greater. I'm like, okay, for the first time when you encounter I'm also going to have boolean check false, and initially once this happens once, then I will check equals to true, and you only go here if check a equals to, if not check, or maybe I can just say if it is not check, then you go here, right, and if you found out that it is true, then I just say plus plus. I don't need, because if there is one of them which has a, if they are not equal, it continuously go, and once you found that they are not equal and so strictly greater than it, there are this many elements, then you add to the answer, and now you are always going to add to the answer and just return answer. That's it. That's what you need to do. And yeah, I forgot to do this. INT-n is just nums.size. Alright, so it's 2, and this is also, this is 0. So I have no idea why it is giving 2, because it's never, if I am at n minus 2, then I'm at here, and I see that nums of I is equal to nums, so it's not going to happen. Yeah, this I'm only going to make this if there is a check. Not check, I'm going to only do this. Yeah. As you can see, 0 and 2. I think this should work. Hoping. Okay, it didn't work. So k equals to 0 is also a thing. So if k equals to 0, if k equals to 0, then I just return the web n, right, all the numbers are. But if k equals to 1, then I can do the same thing. Yeah, these are, I didn't see how much k would have been. So I think this should work. Got expected. Okay, now let's talk about maximum substrings with distinct start. Maximum substring with distinct start. You are given a string as consisting of lowercase English letters. Lowercase English letters. Denoting the maximum number of substrings you can split as into such that each substring starts with a distinct character. Okay. We return an integer denoting the maximum number of substrings. Maximum number of substring you can split as into such that each substring start with a distinct character. Okay, so I need to split as into such that each substring start with a distinct character. There is no two substring with the same character. Okay, how can I do that? So let's say I have A and B and A, let's say. So there will be a maximum 1, 2 and 3, right? But when will I have problem in doing this kind of things? So let's say that I have A and there are a lot of A's, right? And then I encounter a B. I'll be like, okay, get to the next substring, make it the next substring, and then let's say I encounter an A again. I will like, okay, then make that particular thing a substring again. Then no matter how many times I do, I'll be like, okay, so there will be two. If you look at this, no two substrings with the same character. Okay, alright, this changes the question. So the maximum substring that I can take is such that no two characters are the same, right? Okay, maybe I can actually have a set and try to do it greedily. Set character st, right? Now this is going to have certain characters, and I'll be like, okay, if this character exists, then I won't make that particular, try to make that particular substring, right? If it does not, if I see it for the first time, then I can do that. Maybe I should also try to do binary search on this thing, but I'll do that later. Like, first of all, I will see if the first character of the letter, if it does not exist, I'll take that. Obviously the first character I will take no matter however it goes. As soon as I find something different, I'll take that. What if I didn't take it? Whenever I find a new thing and I didn't take it, I wanted it to grow. Later when I take it, will it make it better choice? Will it make my answer better? That's the thing. Of course not, right? If I don't take, there might be A's now. Don't want to take A's. So I think greedily works, because if I try to take it and if I don't take it, then I don't have that particular thing. Even though I don't have that particular thing, maybe I can take something else, but I can also take that particular thing. Then if I could have taken that, if I can take another something different, then I would again, okay, yeah, I think I can do it greedily. So int I equals to mixtest dot length, and I will be like, okay, go to s of I. So or maybe I should do it something like, okay, int I equals to 0, and while I is less than n, and now if st dot find s of I equals to st dot end, then in the set you try to find that character and you didn't find it, then I'll be like, okay, set dot insert s of I, right? And then you just do your usual I plus plus. If you didn't find, I'm still going to do I plus plus, correct? That's what I'm going to do. And the size of the set is just going to give me the answer of this particular question. 2, 4 and 1, which is the truth. And let's submit this question, and it did get passed. Let's try to do this. Oh wait, somehow I already did this. what happened? What did I do? Okay, whatever. Let's try to do it again. You are given an integer randoms, a mirror plane of indices I comma a mirror pair is a pair of indices I comma j such that okay I is less than j, j is less than nums dot length. Okay, reverse of okay. I think I remember this. The minimum absolute difference between any pair and reverse pair. Absolute distance between. Okay. There's that. Okay, there are two different. I take two different indexes, and then when I try to devise up this the ith index, then it becomes a jth index. Correct. It becomes the jth index. Then I'll be like it's a mirror pair. Return the minimum absolute difference between the indices of any mirror pair. Minimum absolute difference. Okay, I need to return this thing, the minimum absolute distance between a mirror pair. Alright, so how can I do this thing? One thing is to do it in n square, but n square won't work here. So I need to be a little bit smart and do it somehow, that if I mirror all of the things and maintain a set, then I'll be able to do it. If I try to maintain a set, but if I make a set, this could happen that the n square. Okay. After I reverse them, that should be able to be somewhere from the back. And how do I do it exactly? If I try to have a set, so my thinking is I want to have a set trying to have a set from the back, and or maybe a map will do, and the map is going to be of the reverse numbers, so the reverse number for everything. So let me do it. Map int mp, and right now I'll obviously have no reverse pair, so let me have a reverse function here which is going to give me the reverse. So if I have int nums int n, okay, so what I'll do, I'll convert it at first to string. Okay, now I'll be like, okay, reverse this thing. Well, even if I don't take a string, I can still try to reverse it. should I do that? That's the thing. Yeah, I think I should definitely do it. You were right. If I want to reverse this thing, then I'll have to. Okay, I'll have to take number, let's say answer, which is 0 initially, and I'll be like, what multiple of 10 is this thing? So that will give me how many digits are there. So like how much power, how many digits are there, or maybe okay, so I can find the digits like this. Digits will be 20 x equals to n, or maybe 10 x equals to 10. Okay, and now I'll be like, okay, while n is greater than 0, I mean n is less than x, I'll be like, okay, so this means there is one digit. So n, so digit plus plus and x multiply equals to 10. Correct? This is what I'm going to do. This will tell me that the digits of first digit, second digit is on third digit, fourth digit, fifth digit still equal, and now it will be like a digit minus minus, right? This many digit it has, and now I'm going to use the answer. Okay. Well, maybe I should not do so many things, because if I do digit minus minus, now I know that digit, I'll be like, okay, I also need a power of this, so, or maybe even if I don't take the power, I also don't want this digit variable. Actually, this x is enough. The x is actually enough. So I'll be like, okay, let y be 1, and I don't need this digit. Okay. Now again I'm going to do n is less than equals to 0. What am I going to do is fairly simple. I'm just going to, y, I'm not converting it to y because there might be some issues with, even if there will not be any issues, but it's n log n. I don't want to take risk. That's why I'm doing it. So at first, the first digit, entry digit, is going to be n modulo 10, correct? And n modulo 10, I'm going to add it to the answer. So plus equals to n modulo 10, but I'm going to multiply this by x actually. Why is this? Because okay, x divided equals to 10. Okay, because that many, how many zeros this has? That many plus 1. So this is perfectly fine. and then I'll be like, okay, do this, and n also divide equals to 10, and then in this way I'll be like, okay, now I have the next number and I'll put that until n becomes 0. Okay, so now I'll just return, and that's it. That's how I'm going to reverse it. So now I'm going to be like nums of I, or maybe n minus 1, and n I have not defined it, so let me define what n is. Nums dot size. Alright, this is obviously nums of n minus 1 is equals to, okay, I'll need to revert this. So revert, I need revert and this will be mp of nums, this will be n minus 1. Okay, now I'm going to start with I from n minus 2, and okay, I is greater than equals to 0, I minus minus, correct. And I'm also going to be, anti answer, which will be initially int max, let's say, and if it's still int max, then I have nothing to do. Okay, so int x equals to river of nums of I, right? Okay, I have got the x. Now what will I do? I'll be like, okay, in the map, do I have something like this? Do I have something like this? Then answer equals to min. So if mp dot find x is not equals to mp dot n, which means there is something like x in the map, correct? Then I'll be like, yeah, give me that index, and I'm at which index? I, and I'll be like, okay, the answer is equals to min of answer comma, as you can see I need the difference between the, so yeah, I think this will do. Yeah, this will do, but if this is only if I don't find out, then I can do nothing. Now mp of x is equals to I, that's it. And now I just if answer is equals to int max, and return -1, else I return answer. I think this will work. Let's see. Okay, first one is 1, I don't know why. Maybe this has to do something with this. Maybe this was not clear. Let's talk about this. Like multiplying x, what it was 1, it was here, and mp of river of nums 1 minus 1. Okay, I don't know what's happening, but this should have been given me. Everything is just -1. I'm taking the min. I don't know what's happening. If it finds x on that, then only do that. Okay, alright, I think Okay, I think it's quite the opposite. I don't need to take the reverse of that particular thing. Alright, I think I've done a mistake. Nums of I. If this will be nums of I. Nums of I. Oh wait. Reverse of nums of I should be that thing. Okay. Okay, so I did this reverse something. And MP of nums of I will be this. Okay, if I think that can't I find nums of I directly by normally how I find out, can't I do that? I try to find out nums I normally. Okay, maybe I can, but let's not do it. Okay, so if I find out MP of x, then whatever, if I find out MP of x, then there was something, then this is what I do. I think now it should work. Still my giving minus 1, 1, 1 and minus 1. Okay, I think this should work. Runtime error. Overflow. Signed integer overflow. Maybe I should have taken long instead of this. Yeah, I think now this should work. I don't know. Let's see. It did not give me the answer, but I already know the answer. Yeah, I think now should work. Yeah, it got accepted. So let's do the last question, which is a little bit tough. I think I've done this before. This same questions. Okay, you are given an integer array nums and an integer k. Here it is. In one operation, you can increase or decrease any element of nums by exactly k. Okay, so I can increase or decrease any element of nums by exactly k. Alright. You are also given a 2D integer query where each query is I, L and I. Okay, and maybe I'm thinking something like maybe can decrease or something like segment is going to solve this. I don't know, I'm just feeling because there is queries and all of those things. So in one operation you can increase or decrease by exactly k. So I can only do exactly k, not less, not more, by exactly k. And now you also have queries, which is basically going to have some ranges from L to R for this array nums, and for each query find the minimum number of operations required to make all the elements in the subarray nums are equal. If it is possible, the answer for that query is -1. If it is impossible, the answer for that query is -1. Okay, that's really a tough question. I don't know how can we do this. Answer. Okay, so I need to make them equal. And how can I make them equal? Okay, so if they can be made equal if they follow the same arithmetic progression, right? Or else I can never make them equal no matter what I do, correct? Like if somebody is in the high school or maybe 11, 12 reading about arithmetic progression, you can only make them equal if they are arithmetic progression. So if they are not in an so how do I even find out if they are an arithmetic progression or not? That's what I need to do. And if I find out that they all are, representing an arithmetic progression, then how do I find out the minimum? That's fairly easy actually. Once I find out that they're in arithmetic progression, I just need to find out the minimum and just okay. The queries are okay. The queries are of ln r. And then length of the queries are also same as the length of this array. So okay, how can I do that? Okay, how do I do this question? I'm thinking, and then what I will do. Okay, so let me think. Let me see how. What is my rank here? Okay, not bad, I would say, but still not very good enough, because those questions, those are some of the questions that I already solved, especially that question. You can have seen that. Find the minimum of operations required to make all the elements in the sub-array nums equal. If it is impossible, the answer for that call is -1. How do I do that? I need to do some pre-processing, I guess. I mean, I'm sure I'm going to learn something new, or maybe there are something. Okay, so one thing is sure, that it has to be arithmetic progression, but I'm not sure how. Whatever the minimum is, it needs to be an arithmetic progression of the minimum, and so all of them should be something like the minimum plus or minus. If I try to add it up, then I can just make this. Right. Okay, it also depends on how many of them are there. Okay. Even though I can make all of them equal to the minimum, but it doesn't mean that I should do that. Okay, so what else I can do? What else can I do? That's the question. whenever I found out if that is alright, I will check which element has the maximum. Like I want to find that element which has the maximum frequency. So yeah. So let me write it down if what I want. Firstly, I will check the elements in the sub-array form an arithmetic progression with difference k, and obviously I can just check the minimum and do that. Okay. Secondly, what I'll do, I want to find the maximum frequent element. Okay, firstly, if check the minimum, we can just check the minimum. We can, okay, I'll do that later, what we can do or not. So mainly what I want to do is this, if it makes an arithmetic progression or not, and if yes, if no, then -1, if no, then -1, else you go how to find the maximum frequent element on the sub-array, then try to do something, right? You can either increase or decrease any element of number by exactly k. Yeah, I'll find the maximum frequent element on the sub-array, and then I'll have to make then I have to count for each element how many. Okay, and also as we can see that this is really a static query. I am not changing anything. I can actually do a sparse table, find the minimum, or maybe if not sparse table, something like if they are possible to make or not. If okay. Okay, sparse tables, or maybe what can we really do? That is really the question. I have no idea what we can do now. Okay, so at first, if I take the now, if I take how do I take the maximum frequent element? I have no idea. I have no way to take the maximum element. Maybe square root decomposition or something that can do, but it's very complex. I have no idea. Even though this is a static, one thing is pretty sure, this is a static question, right? So I don't need to change anything. Maybe something like merge sort or something like that can do certain things. I don't know. Merge sort is just going to take n log n, right? And when I do merge sort, I can also be sure about, I think I can do merge sort. That will give me, if I do merge sort, that is just going to give me left part. Let's say I have some left part and some right part that I need to check. I can just check which part of the smallest, which part of the subarray does that come from, and which part of this does this come from. Does this come from? Okay, what if they overlap? That's also a very good question. Maybe if I try to implement segment trees, if some things can be solvable with merge sort, maybe segment trees can also work. That's what I am thinking. Thinking is what I can do right now. What can we do really with segment tree? We can just find the minimum, maximum, and if we can make them or not, and if yes, then how many? Yes, to be honest, I have no idea how can I do this. Yeah, so should I like end contest or something? Because there is no way I'll be able to do this question. Just very hard. Mm. Yeah, so yeah, I think I won't be able to do this. 0 to 1. Like, what can I use to find out? Like, if I make problems and I want to increase or decrease an element by k. Okay, I'm thinking, let's say something pre-processed, something like this. TB of let's say L and R. Is what this is going to be, or maybe let's say not, let's not take TB. Let's say that there are functions, and this function is going to tell me if what is the maximum points in which I can make it. So it will be like I can make let's say a subarray R1. I can make this subarray, let's say, and can make or maybe M, let's say M. At M comma R plus 1. There are these two subarrays. I will say that what is the maximum number of things that this makes, and I'll have a maximum in this range, a maximum in like where they are converting. I'll have two things stored, and similarly here also, but that won't make the thing work, right? Yeah, that is not going to make the thing work. No. this won't work. Absolutely not going to work. Sorry, this would be something like this, but this is not really going to work as far as I am thinking. So yeah, I think I've spent enough of time. So let's try to, this is a weekly 478 contest, so let's try to search it on Google, I mean YouTube, for 478 weekly contest 478 solution. Yeah, let's see. Yeah, so this is ARPA, I think. Yeah, he's ARPA. Yeah, let's try to learn something new and how he has done the things. You might be knowing something new.
Hey folks, we are gonna solve weekly contest 478 contest problems on LeetCode in 20 minutes. So join me, the former LeetCode contest coordinator, and I'm gonna solve all problems and you'll see me during this contest. Let's start. This time I'm gonna code using C++, as our polls show that you are more interested in sessions using C++. Okay, it's asking about elements more than k, right? This k is simply greater than okay. For this, we can sort and then go for the element which is okay. So for this, I will take the case greatest element, then the next element, I mean all the strictly smaller elements than this will be the answer. I mean, I'll sort nums that begin.
Yeah, I did something similar.
Nums that end. Then I'll take the size minus k. K can't be 0, right? It can be.
I didn't think
If
of that.
k is 0, I'll go for, let's say, int max, otherwise this. And finally, I will count the numbers less than x. For that, I'll return count if nums that begin. Let me switch to editor. 0 nums dot and int y, return y is less than x.
What is this?
Okay. Okay. What is happening? Okay, I need to log in again. Okay. I will submit. Okay, we got AC of first problem. Let's go to the next problem. You're given a string S consisting lowercase integers, lowercase English letters, maximum number of
Yeah, I did it with
substrings
sets
you
and
can
greedy.
split S into such that
Greedy.
each substring starts with a distinct character. No two substrings start with the same character. Okay, so the answer is at most 26. Answer is basically number of unique characters in its return set is that begin, is that end, that size.
Wait,
Okay,
what
we
is
got
this?
AC. Let's go to the next problem. You are given integer array
Wait.
nums. A mirror
Num.
pair is a pair of indices such that blah blah. Okay. Okay. Minimum absolute distance between the indices of any mirror pair. Okay, but if okay. Seems very easy, right? For each index, we reverse it and save it in like somewhere, some map, and then we check if these integer appeared somewhere, and yeah, that's pretty easy.
Yeah, okay, he's doing like me, but I think he's going to go from the front to the back,
Here.
but I did the other way around. I did like from the back to first. Just, yeah, that's what he's going to do, yeah.
Let's set it to int max at the beginning. If where the count contains
Yes, I don't know these STLs.
x is nums I. If this is minimum of ans and where I minus where x, then I will reverse x. I'll show you how, and then I will insert it into where. I mean string s is to a string
Yeah, he's going to do it
X.
normally.
Then the Rx will be a toy string. Yeah, if I can reverse the beginning, the end, and then this will be a toy of this, and where Rx will be I, and finally return as is
Okay, he really did
max
all of this in
-1, otherwise
really
ends.
fast, like in almost
Try.
10 minutes. He did all of
Okay,
them.
if you can't recognize this, I will go with story. 1 1 -1. Let's submit. Okay, we got AC. Let's proceed to the last problem. Okay, this seems like a hard problem with 7 points. You're given an integer array nums and an integer k. In one operation, you can increase or decrease any element of nums by exactly k. Okay, you're also given to the integer array queries where each query is a range. For each query, find the minimum number of operations required to make all elements in subarray equal. Its impossible answer is -1. Okay, so all of them should have the same modulo by k.
So he did
Sure.
this in how many minutes? He's taken a lot of time, I think. I don't know if he's taken a lot of time or not, but it seems like he has the solution accepted here, and there are also some runtime errors and a lot of runtime errors, but yeah, that's not a big issue.
Like 1, 4, and 7 all have the same modulo by 3, but for example here 1 and 2 they don't have, so that happens. This is not that much, but okay. What we will do is first making sure all these elements form have some same modulo by k, which is actually easy, right? For each index, we will count how many integers to the left of it have the same modulo like this by k, and then I will check for r if the number of elements to its right, I mean continuously, that is equal is this in modulo by k is more than r minus l. That's about yes and no, but for minimum. For minimum, what we should do is dividing all integers by k. And we want to make all of them equal. For making all of them equal, we should convert all of them to same integer, which is their median. This is a fact. You should already know about it
Median.
if you want to solve this problem.
What?
And then
Not
then what
median.
happens? Then what happens is, so we want to get some of its elements smaller than it and greater than it. So I have a segment tree idea, but not sure if it's the best thing I can do. Square root decomposition also works, and it's much better. I prefer it so much because for sure it's yeah, let's go for square root decomposition.
Okay.
I will sort all elements in each block, then I will count how many integers is more than not counting, I mean getting some of them, some of elements which is bigger and some of elements which is smaller, and then we can handle that. Okay, seems we are gonna have a bit of story. Okay.
Okay, instead I should see something else. Yeah, I think I should see this. Yeah, from IT Dhanbad. Yeah, obviously I'm live. A to C. So A to C was not that difficult to, but I think we should see the question fourth. Let's see how he solves it.
Hey, hi, Rajan this side. Welcome back to the channel. So today we'll discuss this fourth problem asked in today's Lead Code Weekly Contest 478. Let's look at the problem statement first. It says you are given an integer array nums and an integer k. Now in one operation you can either increase or decrease any element of the nums by exactly k, right? And you are given a 2D integer array query. So in each query you will be given a left index and the right index, right? Now for each query, what you have to do, you have to find out the minimum number of operations required to make all element of the subarray from this li to ri equals, right? And if it is impossible to make all the elements in this subarray from li to ri equal, so if it's impossible, then you have to return -1, right, for that particular query. Now, so overall, you should be returning an array that contains the answer for each of these queries, right? And we know what is subarray. Yeah, it's a good problem. Let's see how we can approach it. In fourth problem, as per the problem statement, we have to make all the elements in this subarray from li to ri to same number, right? And by following the operation, and operation is to either increase or decrease any of the elements by k, right? So let's say this is a subarray, right? This is the subarray, and this is the left index and this is the right index, right? So this is the ith query, right? Ith query. So you are given left index and right index, and you have to make all elements same, right? By following the operation. So let's consider there are two elements x, right? So the number that is present at this index is x, and the number that is present at the another index is y, right? So both the indexes are different. So we have to make all the elements, like both the elements same, right? So what it means? It means that let's say let's say the target element, like, so after, so both the number has to be same, right? Like after following the operation, let's say after following operation this become t and this is also become t, right? So then only they would be this both number would be same, right? So I'm taking two numbers just for a generalized case, right? So it would work for all the, like, so every pair of numbers in this subarray. So let's say after conversion this becomes t and this also becomes t, right? So now both are become equal. Now since this t is obtained by applying some operation on this element x, right? And similarly this t is obtained by applying some operations on this element y, right? So can we write t equals to x plus minus, right? So plus minus some let's say this is p number of time applying this k operation, right? So p into k means that, so either you subtract or add, right? So it's like as per the problem statement, in one operation you can either increase or decrease any element of the number by exactly k, right? So this is your like original element x. Now you apply some number of times either like all addition operation or subtraction operation, doesn't matter. So like we can always represent t as x plus minus p into k, right? Similarly t also equals to y plus minus, let's say this is q into k, right? Since t same, so can we write x plus minus p into k is equals to y plus minus q into k. Let's rearrange it. So it would be x minus y is equals to something plus minus p into k plus minus q into k, right? Let's take k common. So x minus y is equals to k multiply some plus minus p plus minus q, right? So this can also be represented as x minus y is equal to k into mod of p minus q or p plus q, it doesn't matter, right? So ultimately this is an integer value, this is an integer value. So what it means, since this is an integer value, this is k into k, can we write x minus y modulo k is equals to some k into some this integer value, let's say this integer is z modulo k, right? So I just take modulo on both sides. So this is 0, right? Because k into something modulo k is always be 0. So it means x minus y modulo k is equals to 0. And like as per the number theory, if x minus y modulo k equals to 0, it means that x modulo k is equals to y modulo k. This is the relation. So what it says that in a subarray, if you want to like make two elements same, right? So if you want to make both the elements same, right? So both remainder has to be same, right? X modulo k must be equals to y modulo k, then only you can make both the elements same, right? Otherwise like it's not possible. And this applies to all pair of elements, right? So what we can do for each subarray, like for each subarray in L2R, we can check if this x modulo k is same, like the remainder value is same or not. So if the remainder value for all the numbers in this subarray is same, then only we can find out the answer. Otherwise we can find out, not find out, so just your answer is -1 in that case. If the remainder is same for all the elements in this subarray L2R, then only you can find the answer. If the remainder is not same, then your answer is -1, right? So I hope you understand this part. Now the next step is to find out this value t, right? So this t is the number that is obtained after converting all the elements into that number, right? So we have to convert all this subarray to t, right? So all the elements are converted into this t. Now let me write a recurrence relation. So I hope you understand this part. So let me erase it now. Right? So
recurrence relation, guys.
Yeah, so yeah, now we know that all these elements are converted into t, right? So this array would look like t and something like this, right? So all the elements are converted to t, right? So all the elements are same. Now we have to find out the minimum number of operation, right? So let's see what would be the total operation. This total operation would be, is nothing but summation of I is equal to I is equal to L to R mod value of let's say this array is A, right? Mod value of A of I minus T, right, divided by K. So this is the number of operation that would be required, right? So we know that we have to convert each AI from this L to R to T, right? So the number of operation would be the difference divided by K. So this is the difference divided by K. And so let me so since this K is constant, right? So if this K is constant, and then ultimately we have to minimize since like we have to find the minimum number of operations. This is the total number of operations, and we have to minimize this part. Since K is constant, can we write this is nothing but minimize A of I minus T, right? Summation of A of I minus T. Actually this is a very well-known optimization technique, right? So this always turns out to be a median value. This always turns out to be a median value. Always. So I have couple of theorems online. So the median minimize the mean of absolute error. So like we can also call, like we also call it error, absolute error. So there are a couple of theorem which I found online. So just to let you know. So this is one of them. So the median always minimizes the sum of absolute deviation.
Okay.
There is
I have a follow-up, like maybe disprove. I want to disprove this. Okay. Let's say a sketch. What if I had something like, yeah, so if I have something like 1, 2, 3, and 4. Now if I want to try to make the operation, what will the operation be? I can try to make this 4, but then this when I try to maximize this, it will be larger. I need to make this very large. I think median is eventually the minimizer. But the thing is, what if I have there was odd number of things. What if I have an even number? Then what are you going to do? I can make this one time and 2 times this, correct? But I can also make these guys not work a bit, but these guys work a lot, right? So 1, 2, 3, 4, 5, 6, correct? So 6 operation. Or if I wanted to make it 3, then 1, 2, 3, 4, 5, 6. So yeah, they are the same thing. So either I take this or this, it's going to give me the same thing. Really? Yeah. Okay, so I think this, whatever
is one more,
actually the truth.
right? The proof that median minimizes the sum of absolute deviation. So like you can check out these online like tutorials, so we can find out that this always turns out to be a median value. So in order to find out the minimum number of operation, just convert all these numbers into its median number. Just find the median number and convert all the number to the median number. Then only you can find out the minimum number of operation, right? So yeah, I'll share these links like in the description. You can check it out, right? So now since we know that all this number has to be converted into the median, right? So let's see how we can implement this part. This part is pretty tricky. So in this subarray, what we will do, we will try to create two subarray, S1 and S2. Right? So S1 would contain. So let's say there are in total 6 numbers, right? So in 6 numbers, so all the numbers would be. So let's say all these 6 numbers are placed in a sorted order, right? So first 3 number and the last 3 number, right? So first 3 number are the smaller number and the last 3 number are the larger number. So S1 would contain the first 3 numbers, right? S1 would contain first 3 number and the S2 would contain similarly last 3 number, right? So let's say the total number of elements in this subarray is 5, right? If in that situation your S1 would contain first 3 number, right, in a sorted order, and S2 would contain last 2 number. So because in this situation, right, in this situation your median is always going to be this number. Your median would be this number. So what we can do, we can kind of, for each subarray we can convert to multisets, and each multiset would contain like, so let's say if the numbers are same, then just convert equal numbers, otherwise divide it into 2 parts. So first contain 1 extra number, so for 5, 3 and 2, and find out this number. So this number would be your median number, and we will try to convert all this number into median number, right? So now in order to implement this part, so this is all about the explanation, so there is nothing more to discuss. Now the only thing left is to how to implement this part, right? So to implement this part, I have used Amos algorithm first, because we have to handle q number of queries, right? So
yeah, so we need to understand what Moore's algorithm is, right? So let's try to understand what Moore's algorithm is, because I already know what square root decomposition is. I don't really know what Moore's algorithm is. Maybe Moore's algorithm is square root decomposition after all, because as we can see, this guy giving that Moore's algorithm is square root decomposition. I don't know if this is misleading or anything, but yeah, I think it's of knowledge. So I think it's going to be a good video. So let's try to understand Moore's algorithm from this teacher here.
हे गाइस, कैसे हो सब लोग? वेलकम टू अपना कॉलेज। और आज हम करने वाले हैं एक बहुत ही बढ़िया टॉपिक जिसका नाम है एमोज एल्गोरिथम, और ये बेस्ड है जो हमने प्रीवियस टॉपिक सीखा था स्क्वायर रूट डीकंपोजिशन के। सो देखते हैं ये क्या है। तो जो प्रॉब्लम्स का जनरल स्ट्रक्चर होता है जब हमें एमोज एल्गोरिथम यूज़ करना होता है, वो कुछ ऐसा सा होता है। यू आर गिवन एन एरे ऑफ साइज n एंड q क्वेरीज। हमें एक एरे गिवन होगा और हमें q क्वेरीज गिवन होंगी, राइट? या फिर कुछ ऐसा होगा दैट इज रिड्यूसिबल टू अ एरे, राइट? सो ईच क्वेरी इज अ रेंज क्वेरी, ठीक है? कोई भी क्वेरी होगी वो रेंज क्वेरी होगी। इन ईच क्वेरी वी हैव टू परफॉर्म सम ऑपरेशन एंड आउटपुट आंसर ऑफ ईच क्वेरी, ठीक है? कुछ ऑपरेशन करना होगा और फिर उसका आंसर हमें आउटपुट करना होगा। तो इसका जो ब्रूट फोर्स अप्रोच है वो तो बहुत ही आसान है, बिल्कुल सेम एज अपना स्क्वायर रूट डीकंपोजिशन। फॉर ईच क्वेरी हम क्या करेंगे, कंप्यूट द आंसर फॉर दैट क्वेरी, एक लूप लगा के और उसका आंसर कंप्यूट कर लेंगे और जंप ऑन टू द नेक्स्ट क्वेरी, ठीक है? सो इसमें हर किसी क्वेरी का जो टाइम कॉम्प्लेक्सिटी होगी वो ऑर्डर ऑफ n, और हमारे पास q क्वेरीज हैं तो टोटल टाइम हो जाएगा ऑर्डर ऑफ n इंटू q, राइट? और बहुत सारे क्वेश्चंस में हम ये अफोर्ड नहीं कर पाते, तो दैट्स व्हाई वी हैव टू ऑप्टिमाइज इट। तो जो इसका एफिशिएंट सॉल्यूशन होगा दैट विल बी यूजिंग एमोज एल्गोरिथम। और इसमें हम क्या कर रहे होंगे, इसके जो स्टेप्स हैं वो ध्यान से देखिए कि इनपुट ऑल द क्वेरीज साइमल्टेनियसली। इसका क्या मतलब है कि सारी की सारी क्वेरीज को ले लो एक साथ, अभी किसी को आंसर मत निकालो, लेकिन सबको इनपुट ले लो, राइट? और फिर क्या करो, सॉर्ट द क्वेरीज इन अ पर्टिकुलर फैशन। और ये जो पर्टिकुलर फैशन है ये अभी हम देखने वाले हैं, राइट? और ये जो स्टेप है, दिस स्टेप इज़ नोन एज ऑफलाइन प्रोसेसिंग ऑफ क्वेरीज। ऑफलाइन प्रोसेसिंग का क्या मतलब है कि भाई पहले मैंने सारी क्वेरीज ले ली और उन्हें सॉर्ट कर दिया। अब सॉर्ट करने के बाद ऐसा हो सकता है कि जो मेरी दूसरे नंबर की क्वेरी है वो चौथे पोजीशन पे पहुंच जाए, और जो चौथे नंबर की क्वेरी है वो पहली पोजीशन पे पहुंच जाए। तो जो बाद में क्वेरी आई थी उसको मैंने पहले सॉल्व कर दिया, और जो पहले क्वेरी आई थी उसको मैंने बाद में सॉल्व कर दिया। सो दैट इज़ कॉल्ड ऑफलाइन प्रोसेसिंग। और ऑनलाइन प्रोसेसिंग क्या होती है कि जैसे जैसे क्वेरी आ रही है, राइट? मैंने एक क्वेरी ली, उसका आंसर दे दिया, फिर दूसरी क्वेरी ली, उसका आंसर दे दिया। तो दैट इज़ ऑनलाइन प्रोसेसिंग ऑफ क्वेरीज। सो इसमें हम करते क्या हैं, जो स्पेशल फैशन था वो देखिए क्या है। मान लीजिए आपके पास एरे है वही कि 1 5 -2 6 8 -7 2 1 11, राइट? और आपके पास क्वेरीज हैं LR वाली, ठीक है? सो इसको जो हम सॉर्ट करते हैं क्वेरीज को, वो ऐसे करते हैं कि अगर हमारा जो L है, राइट, किन्हीं दो क्वेरीज का हमारा एल अगर सेम रूट एन के ब्लॉक में लाई कर रहा है, मान लीजिए अगर हमारा एल इस रूट एन के ब्लॉक में लाई कर रहा है, और तो हम क्या करेंगे, जिस क्वेरी का आर बड़ा होगा, राइट, उसको पहले रख देंगे और जिस क्वेरी का आर छोटा होगा उसको बाद में रख देंगे। और वहीं अगर ये वाला केस नहीं है, सो जिसका एल पहले वाले रूट एन के ब्लॉक में लाई करेगा उसको पहले रख देंगे।
Okay, I don't understand. Let me try to understand square root decomposition from our code story with Mike, which is currently one of my favorite YouTube channels.
Hello everyone, welcome to my channel.
I learned segmentary from this guy.
Code Story with
He
Mike.
teaches really well.
अपने मैथ्स कंसेप्ट्स एंड क्वेश्चंस की प्लेलिस्ट का वीडियो नंबर 6 करने जा रहे हैं। मोटिवेशन देखते हैं आज का। द गोल विदाउट अ प्लान इज जस्ट अ विश। ऑब्वियस सी बात है, आपने गोल बना लिया, बस आपके पास कोई प्लान ही
Goal without a plan is just a wish.
नहीं है,
Yeah.
तो उसको विश की तरह ही समझो और वो ख़त्म भी हो जाएगा। बट अ प्लान विदाउट एक्शन इज जस्ट अ डे ड्रीम। दिन में सपने देख रहे हो, मतलब आपके पास प्लान है बट आप उस पर एक्शन नहीं कर रहे हो, तब तो आप गलत कर रहे हो बिल्कुल। इसीलिए ब्रेक योर लॉन्ग टर्म एम्बिशंस इनटू स्मॉल मैनेजेबल टास्क्स। एक बार में सब कुछ करने की मत सोचो, स्मॉल टास्क में तोड़ो और एक एक करके उन छोटे छोटे टास्क को टैकल करो। द क्लैरिटी ऑफ अ गुड प्लान गिव्स यू द कॉन्फिडेंस टू एग्जीक्यूट व्हेन थिंग्स गेट टफ। ओके, तो आज का टॉपिक क्या है? स्क्वायर रूट डिकम्पोजिशन। इट्स नॉट अ वेरी डिफिकल्ट टॉपिक, बट इसके और भी यूज़ केसेस हैं जो कि बहुत अच्छे हैं, जो कि फ्यूचर वीडियोज़ में आएंगे, बट ये समझना ज़रूरी है और कई जगह ये यूज़ भी होता है। ओके, तो देखते हैं ये कहता क्या है। पहले तो ध्यान से देखो, यहाँ पर क्या लिखा हुआ है? स्क्वायर रूट लिखा हुआ है ना। तो इस टर्म पे ध्यान देना। स्क्वायर रूट लिखा हुआ है, डिकम्पोजिशन मतलब तोड़ना। तो इन दोनों टर्म का मतलब तो समझ में आ रहा होगा, बट इसका यूज़ क्या है वो समझते हैं। एक बड़ा सिंपल सा मैं आपसे सवाल करता हूँ। मान के चलते मैंने आपको एक एरे दिया है, मैंने बोला यार इस एरे में 9 एलिमेंट्स हैं, मान के चलते एग्जांपल के तौर पे ले लिया, और मैं आपको बोल रहा हूँ यार कि एक क्वेरी है मेरे पास, क्वेरी 1, कि तुमको L इज़ इक्वल टू, मतलब इंडेक्स इज़ इक्वल टू 1 से लेकर इंडेक्स इज़ इक्वल टू 5 या 6 तक का सम चाहिए। फिर मैं तुमको बोलूँ कि यार मुझे क्वेरी इज़ इक्वल टू 2, यानी कि L इज़ इक्वल टू 0 से लेकर R इज़ इक्वल टू 5 तक का सम चाहिए। मान लेते हैं ऐसे क्यू क्वेरीज थे, है ना। हर क्वेरी के लिए आप क्या करो, L से R इटरेट कर लो, फॉर लूप लगा दो, है ना। फॉर लूप लगाओ,
Yeah, I know this. N times Q will be the time
है ना। और अगर N
complexity.
बहुत बड़ा हो तो ऑब्वियस है टाइम लिमिट एक्सीड आ सकता है। तो आपके मन में आ सकता है यार ऐसे प्रॉब्लम्स को सॉल्व करने के लिए तो हमने ऑलरेडी बहुत चीज़ें पढ़ रखी हैं। एक तो है क्यूमुलेटिव सम निकाल दो, क्योंकि आपको सम ही तो निकालना है सिर्फ, है ना। तो इसका क्यूमुलेटिव सम निकाल दो, और L से लेकर R तक का सम चाहिए, तो क्यूमुलेटिव सम ऑफ R माइनस क्यूमुलेटिव सम ऑफ L माइनस 1 निकाल दो, तो L से लेकर R तक का सम मिल जाएगा। हाँ ठीक है, वो भी सही है, बट यहाँ पर क्यूमुलेटिव सम है। हो सकता है कोई और यूज़ केस आ जाए फ्यूचर में कि यार आपको L से लेकर R तक का आपको प्रोडक्ट चाहिए, या फिर हो सकता है कुछ और भी पूछा जा सकता है। बहुत सारे वेरिएशंस हो सकते हैं इसके, ठीक है। और सीखने में क्या जाता है, एक और तरीका सीख जाओगे कि किसी रेंज का सम निकालना कैसे जाता है। और एक और चीज़ मैंने आपको ऑलरेडी पढ़ा रखा है कि भाई सेगमेंटरी से भी बना सकते हो आप ऐसे प्रॉब्लम को, कि क्वेरी आपको दिया हुआ है और हर क्वेरी का जो इंडेक्स दिया हुआ है उस इंडेक्स के बीच का सारे एलिमेंट्स का सम चाहिए आपको, तो सेगमेंटरी से भी कर सकते हो, है ना। तो अब एक और तरीका है स्क्वायर रूट डिकम्पोजिशन, जिससे आप इसको सॉल्व कर सकते हो। तो ऑब्वियस सी बात है, इससे तो बात नहीं बनेगी, ये टाइम लिमिट एक्सीड दे देगा, है ना। तो अब देखो इसका नाम देखो, टेक्निक का नाम ही है स्क्वायर रूट डिकम्पोजिशन। मतलब बोल रहा है कि तोड़ेंगे हम स्क्वायर रूट में। इसका मतलब पता क्या हुआ, अगर आप नोटिस करो इस टाइम कॉम्प्लेक्सिटी को ध्यान से देखो, ये है Q टाइम्स N, है ना। तो आप एक बात बताओ, Q को तो आप चेंज कर ही नहीं सकते, ये तो फिक्स्ड है। क्योंकि मान लेते हैं आपसे Q क्वेरीज किए जा रहे हैं, तो आप उसको थोड़ी ऑप्टिमाइज़ कर सकते हो, ये तो फिक्स्ड है कि आपसे Q क्वेरीज किए ही जाएंगे। अब आपके पास इसको इम्प्रूव करने का एक ही ऑप्शन है कि आप इस N को इम्प्रूव करो। और ये नाम देख लो क्या बोल रहा है, स्क्वायर रूट। तो पता है एक्चुअली में क्या बोल रहा है कि आप इसको इम्प्रूव कर सकते हो O ऑफ Q टाइम्स ऑफ रूट ऑफ N, स्क्वायर रूट ऑफ N। इसीलिए इसका नाम यही पड़ा है स्क्वायर रूट डिकम्पोजिशन। तो स्क्वायर रूट ऑफ N का मतलब क्या है यहाँ पर वो समझो। पता है स्क्वायर रूट ऑफ n का मतलब क्या है? n याद है क्या था? n मेरा नंबर ऑफ एलिमेंट्स है यहाँ पर, है ना, यहाँ पर n नंबर ऑफ एलिमेंट्स है। तो स्क्वायर रूट ऑफ n क्या होगा वो समझो। मान लेते हैं n आपका अगर 9 है ना, तो स्क्वायर रूट ऑफ n क्या होगा?
3.
स्क्वायर रूट ऑफ 9 दैट इज़ 3। और यही वाला एग्जाम्पल मैंने ले लिया है जिसका साइज़ n इज इक्वल टू 9 है। तो देखो ये पता है स्क्वायर डिकम्पोजिशन क्या बोलता है कि अगर मैं आपको L से लेकर R तक का सम पूछता हूँ तो एक एक करके सभी एलिमेंट्स में मत जाओ। इससे अच्छा क्या करो, उनको स्क्वायर रूट ऑफ n के चंक्स में बांट दो। पहले इस पूरे अरे को स्क्वायर रूट ऑफ n के चंक्स में बांट दो। स्क्वायर रूट ऑफ n का वैल्यू 3 है ना, तो ये क्या बोल रहा है, 3 3 के चंक्स में बांट दो। ये देखो 3 का एक चंक बन गया, ये 3 का एक चंक बना और ये 3 का एक चंक बना। ओके, और ये क्या बोल रहा है कि ये जो चंक है हर चंक का सम स्टोर कर लो। जैसे मान लेते हैं टोटल कितने चंक बने, टोटल 3 चंक बने ना, 1 2, और इसका नाम दे देते हैं, चंक बोलो या तो ब्लॉक बोलो, कि मेरे पास टोटल ब्लॉक्स 3 ब्लॉक्स बनकर आए हैं। ऑब्वियस बात है 3 ही आएंगे, क्यों? क्योंकि टोटल 9 एलिमेंट्स थे, है ना, और आपने 3 3 का ग्रुप बनाया, 3 3 का ग्रुप बनाया, तो ऑब्वियस है 9/3 इज इक्वल टू 3, यानी कि टोटल 3 ब्लॉक्स बनकर आएंगे। वो आपको साफ साफ दिख रहा है, 1 ब्लॉक, 2 ब्लॉक और 3 ब्लॉक। ओके, तो यहाँ पर 3 ब्लॉक बन गए। ये मेरा ब्लॉक नंबर 0 है, मतलब इंडेक्स नंबर 0। ये ब्लॉक नंबर 1 है, मतलब इंडेक्स नंबर 1। ये ब्लॉक नंबर 2 है, यानी कि इंडेक्स नंबर 2 इस ब्लॉक एरे का। और ये क्या बोलता है कि इस ब्लॉक का सम पहले ही स्टोर कर लो, 2 + 3 + 1 3 तो 5 1 6 यहाँ स्टोर कर लो, और इस ब्लॉक का सम यहाँ स्टोर कर लो, 5 2 7 6 13। इस ब्लॉक का सम यहाँ स्टोर कर लो, 8 1 9 3 12। ओके, और इन ब्लॉक का सम भी स्टोर करना बड़ा आसान है। देखो कितना इजी है, मैं आपको दिखा देता हूँ। जैसे मान लेते हैं आपका इंडेक्स i यहाँ पर है, तो देखो इस ब्लॉक में जितने भी इंडेक्स हैं, इंडेक्स नंबर 0, इंडेक्स नंबर 1 या इंडेक्स नंबर 2, और हमारे पास टोटल कितने ब्लॉक्स थे, हमारे पास टोटल ब्लॉक्स थे, ब्लॉक्स का काउंट कितना था, 3 था, है ना। तो देखो जितने भी इंडेक्स हैं यहाँ पर, उन सभी को अगर 3 से डिवाइड करोगे ना, तो देखो ब्लॉक्स का 0 ही इंडेक्स आएगा। देखो 0/3 कितना होता है, 0 होता है, 1/3 0 होता है, 2/3 0 होता है। पता है इसका मतलब क्या हुआ कि इन तीनों एलिमेंट का सम ब्लॉक 0 में जाएगा, है ना। सिंपल सा मैथ है। सिमिलरली यहाँ पर देखो, ये है, इस ब्लॉक को देखो, इस ब्लॉक में इंडेक्स है 3, इंडेक्स 4, इंडेक्स 5। इन सबको नंबर ऑफ ब्लॉक से डिवाइड करो, 3/3 4/3 5/3। देखो वैल्यू 1 आएगा, 1 3 4/3 1 होता है, 5/3 भी 1 होता है। तो देखो इसका मतलब क्या हुआ कि ये तीनों एलिमेंट का सम ब्लॉक 1 में जाएगा, है ना। सिमिलरली यहाँ देखो, इस ब्लॉक में इंडेक्स नंबर 6 7 और 8 है, तो इंडेक्स नंबर 6/3 7/3 8/3। 6/3 कितना 2 होता है, ये भी 2 होता है, ये भी 2 होता है। इसका मतलब इन तीनों एलिमेंट का सम इंडेक्स नंबर 2 पर जाएगा ब्लॉक्स एरे का। तो बड़े आसानी से आप इस ब्लॉक्स एरे को भी फिल कर पाओगे, इनका सम निकाल पाओगे। देखो मैं आपको करके अभी दिखा भी देता हूँ। आई थिंक जितना ड्राई रन करूँगा उतना आपके लिए बेटर होगा। ये देखो मैं क्या करूँगा, मैं सिंपली अपने नम्स एरे, जो भी मेरा नम्स एरे दे रखा है उस पर इटरेट करूँगा। इंडेक्स i मेरा मान लेते हैं यहाँ पर है, और इससे पहले मैं ऑलरेडी निकाल लूँगा कि भाई मेरा जो ब्लॉक साइज़ होगा वो कितना होगा। ब्लॉक साइज रूट ऑफ 9 निकाल लो। रूट ऑफ 9 कितना हो जाएगा, रूट ऑफ 9 3 हो जाएगा। इसका मतलब क्या हुआ कि 3 3
later. My parents are telling me to eat. Okay. So bye bye. That's what it is for today.